Welcome to your Algebra 2 Lesson 4.2. Today we are going to talk about graphing quadratics in vertex form. Okay, so obviously your objective is going to be to graph quadratic functions in vertex or intercept form. There's actually two forms that we're going to cover today. In this first video, we will talk about vertex form. In the second video, we will talk about intercept form. So vertex, and you just need to know, you need to memorize both forms of a quadratic. You also need to memorize how to find the vertex, the axis of symmetry, and all the other information about these different forms. Okay, so y equals a times x minus h squared plus k is the vertex form of a quadratic because we're going to be able to read h and k straight from this form, and that's the vertex. Okay, so the graph of y equals a times x minus h squared plus k is the parabola y equals ax squared translated horizontally h units and vertically k units. So left or right h units, up or down k units. The vertex is hk. The axis of symmetry is x equals h. It's that vertical line that runs through the x coordinate of the vertex. The graph opens up if a is greater than 0. Remember that means the whole parabola is positive if a is positive, so it looks like it's smiling at you. And it opens down if a is less than 0. So if a is negative, the whole parabola is all negative and it looks like it's frowning at you. So there's some things that are still true from last class period. You still get to interpret A the same way. The axis of symmetry is always x equals whatever that x coordinate of your vertex is. Okay, so let's put this into practice. We have y equals negative 1/4 times x plus 2 squared plus 5. Now we do want to think of that as x minus negative 2 squared because the form is x minus h squared, so that's going to be important when you determine what a, h, and k are. So we want to identify the constants. A is negative 1/4. You just get it straight off the equation. H is negative 2, and again that's because the formula is x minus h squared, so x plus 2 adding a positive is the same as subtracting a negative, so it's the same thing as x minus negative 2. So h is negative 2, the formula is plus k, so the plus 5 means k is 5. A is less than 0, so it's negative, so that means the parabola opens down. It's frowning at you. All right, for step 2, we're going to plot the vertex. So we want to plot the point HK, negative 2, 5, and then draw the axis of symmetry x equals negative 2. And so far on your graph paper, that's what you should have. You should have the point negative 2, 5 plotted, and then the vertical line through the vertex x equals negative 2. Now remember, I tend to make this a broken line because it's technically not part of what we're being asked to graph. It's just associated with it, and it will help you in the graphing. Symmetry is a beautiful thing. Okay, we're going to evaluate for the function for 2 values of x, and then we're going to use symmetry to get 2 bonus values. All right, you want to pick nice values to work with. Since we have negative 1/4 as the a value, it's going to be helpful for us if we keep whatever's inside the parentheses there even. So instead of taking, going one step back and then another step back, we're going to go by 2 steps. Okay, we're going to go by 2s. So we're going to look at x equals 0. Actually, we're going to go 2 forward. We're going to look at x equals 0 and x equals positive 2. And that's just so that when we evaluate, we get nicer numbers when we multiply by negative 1/4. Okay, so because we can pick any value for x we want. If we really wanted to, we could work with x equals 0.23, but that's just not going to be nice. All right. So y equals negative 1/4 times 0 plus 2 squared plus 5 because x is 0. 0 plus 2 is 2, squared is 4, so that's where we get the negative 1/4 times 4 plus 5. Negative 1/4 times 4 is negative 1, plus 5 is 4. So the point 0, 4 is on our graph. And if you want to, you can go ahead and plot that. Again, we're going 2 by 2 by 2 because we have an even denominator in that fraction out front, and it'll just give us nicer values. So I'm going to go to x equals 2. So I have y equals negative 1/4 times 2 plus 2 squared plus 5. And just to talk about the simplification a little bit, we get negative 1/4 times 16 is negative 4 plus 5 gives us 1. So plot the points 0, 4, and 2, 1 if you haven't done so already. And then we're going to use the reflections across the axis of symmetry. So here we've got our axis of symmetry and our vertex. We're going to plot the points 0, 4. And then we're going to plot the point 2, 1. And then we're going to use symmetry to plot the 2 other points. So let's look at that. Okay, so here we've got our vertex at negative 2, 5. Here's our point 0, 4 and our point 2, 1. So 0, 4 is 2 units to the right of the axis of symmetry. So we're going to stay at y equals 4 and move 2 units to the left of the axis of symmetry. The point 2, 1 is at y equals 1. So we're going to stay at y equals 1. Let's count how many spaces it is to the right of our axis of symmetry. 1, 2, 3, 4. Okay, so that means we need to have a point that's reflected across the axis of symmetry 4 units to the left. So that puts us right here. Okay, and so that is at negative 6, 1. Okay, and then you draw your nice little parabola through the points. So stop and think about, okay, this is downward opening, so did I have a negative for my A value? I sure did. So that's just a little hint that we're on the right track. Okay, we're going to look at an example from civil engineering. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by the function y equals 1 over 7,000 times x minus 1,400 squared plus 27. So A is 1 over 7,000, h is 1,400, and k is 27. Where x and y are measured in feet, what is the distance d between the 2 towers? So we want to know how far apart are the 2 towers. Well, our vertex actually is the key to solving this problem. The vertex of the parabola is 1,427. Okay, so let's look back. That would be right here. Okay, that's 1,427. So the minimum distance up, or the minimum height, the lowest point, is 1,400 feet from the left tower. Because the heights of the 2 towers are the same, the symmetry of the parabola implies that the vertex is also 1,400 feet from the right tower. So looking back, we know, okay, here's our vertex, and x value is 1,400. So up to here, that's 1,400, and then because of symmetry, we know from here to here is 1,400. So we can just add 1,400 plus 1,400, or multiply 1,400 times 2, and get that the distance is 2,800 feet. So pretty easy to work if you understand the relationships. Okay, we're going to come back in just a minute and talk about the intercept form of a quadratic. So I will see you in video 2.